Hello, my Calc 2 student. This is last section we covered this week, inverse trigonometric function integration. If for found derivative we need remember or try remember it's 6 formula, here we need only 3 because how you remember some of formula different only sign for integration. Okay, this we have this kind of theorem to tell us first integral du over square root of a square minus u square, whereas a is constant, equal arc sine u over a plus c. Second one, integral du over a square plus u square equal 1 over a arc 10 tangent u over a plus c. Plus c. And third one, integral du over u times square root u square minus a square equal 1 over a arc secant absolute value u over a plus c. Remember, please, all this situation a is constant. Okay, great. Proving sum of this formula. Okay. For example, number 1. And before we start proof, remember coefficient 1 over a we have for second and third one and don't have for first one. It's easy for remember you. Okay, let's go. We need evaluate integral du over square root a square minus u square. Because a is constant, I can take it out from a square, and I have the situation is du a, because a square out, it's mean from root it's equal to like a 1 minus u square over a square, or u over a, and all together a square. Great. Here I'm trying to integrate. I'm using new substitution, u over a. Let's go this c, and then the u over a. This will be the c. Use this fact, I can rewrite my integral like dc over square root 1 minus t squared. If you remember formulas I give you last time, it will be exactly derivative arc sine t. This means if you integrate, it will be arc sine t plus c, or it will be arc sine u over a plus c. How you can see, we prove first of our formula. Okay, let's go. Let's go moving for next one. I think we prove second one, and third one you can do it yourself. Okay, or believe me, it's absolutely same. Integral du over a square plus u square. Same. I try rewrite a square out. Here we have 1 plus u over a square and it's equal, same substitution, u over a like t, du over a, it will be dt. But here we have dt, but because we have a squared there, 1a we use for dt and 1a is left over. And I can write out of my integral because a is constant here. And here I have denominator 1 plus t squared. Last time we proved this is exactly derivative of our arctangent. This means here we have 1 over a arctangent c plus c, or go back, we have 1 over a arctan u over a plus c. Okay, now see how we can use these three formulas for evaluate our integral. Example. First, we're doing something very simple when you can see how it works with coefficient. Okay. First, we have dx square root 4 minus x squared. What is our situation is? First, we're checking what kind of formula we need to use. Here we have constant minus function, root. This means is formula number 1 is arcsine. What is u here? U is exactly x. What is a here? A squared is equal 4. This means a is equal 2. You use formula number 1. You have its arcsine x over 2 plus c. You see, we can write answer right now. Second question, second example, example B. Here you have integral dx over 2 plus 9x squared. Great. What is u here? Is u squared is 9x squared. This means u is 3x. What will be derivative? It will be 3 dx. This means here I need 3. But because I need 3, I need to write 1/3 in the front. It will be sure is nothing changing. Then, what is a here? We have a squared is equal 2. This means a is equal square root of 2. And now we're ready for right answer. What we have here? 1/3 1 over square root of 2 arc tan 3x over square root of 2 plus c. Maybe I skip a couple of steps. Okay, number C, I try doing it more step by step. It will be more clear. Okay, here we have dx over x square root 4x squared minus 9. Looks like we use formula number 3 here, but what we have, u squared is 4x squared. This means u is 2x. Okay, great. This means here I need 2x squared. And minus 9 is 3 squared. Okay. But because I'm divided by 2, I need multiply it by 2. 2 dx. It's exactly what I need because derivative du, it's derivative to x, it will be 2 dx. Now is our integral ready for writing. What do you have here? 1 over a like coefficient. This means I have 1/3. Arc secant. U is 2x. Divided by a is 3. For arcsecant, we have absolute value, don't forget about, and plus c. Okay. Doing some example who is more complicated. Example when we need substitution, for example. We have one. I think it's two. One we did. Okay. Integral dx over square root e to the 2 power 2x minus 1. Looks like we need substitute e to the power x. Let's go, it will be u. Then e to the x dx, it will be du. Okay. For use this substitution, this means I need prepare my integral. Great. I need e to the power x in my numerical. But I cannot change anything without. This means I write e to the power x as my denominator. X minus 1. But this is great because now I can write, and remember e to the power x is always positive. This means we don't need thinking about absolute value or anything here. Okay, what we have here? We have du in our numerical. We have u times square root u square minus 1. But this is exactly table integral arcsecant u. Arcsecant absolute value u, e to the power x is always positive. This means we have arcsecant e to the power x plus c. You can put parentheses here. It will be sure what arcsecant you take. Okay. Doing one more example. When you have fraction and you need separate for two fractions for solving. For example, I have some x plus 2 over square root 4 minus x squared dx. Easy way for solving here, we separate our fraction for two fractions, and this means we separate our integral for two integral. X over square root 4 minus x squared dx, and second integral will be 2 dx over square root 4 minus x squared. Okay, great. What about first integral? I think first integral we can solving by substitution. I solve it. Here is 4 minus x squared, we write like u, and then minus 2x dx, it will be du, and your integral will be negative 1/2 u to the negative 1/2 power du, who give me negative 1/2 u to the 1/2 power over 1/2, and it will minus square root 4 minus x squared. Great. What about second integral? I use different color. This is exactly 2 integral dx. 4 is 2 square. This means 2 square minus x squared. But it's exactly table integral. It will be 2 arc sine x over 2. And final our answer, it will be minus square root 4 minus x squared plus 2 arc sine x over 2 plus c. This is our final answer. You see, separators will be very simple. Our integrals separate for two very simple integrals. One more type of integrals when we can use inverse trigonometrical function is completing for squares. Doing some first one is a integral dx over x squared minus 4x plus 7. It will be dx, and I work with numerical. Looking here, what I have x squared minus 4x. This means I can write x minus, because minus 4x, and half of 4, it will be 2 square. And always you need subtract square is last square is constant. This means I subtract 4 and add 7. Continue, simplify. I have dx over x minus 2 square plus 3. Great, we have exactly table integral, because this situation our function u is x minus 2 and our a is square root of 3. Because dx and du is equal, this means we don't have problem here, and we write 1 over. And because our denominator is sum u square plus a square, this means exactly arctangent, and we have 1 over square root of 3 arctan x minus 2 over square root of 3 plus c. Okay, great. One more this type of example. Let's go, we have this kind of integral. Integral from 3 halves to 9 fourths. 1 over square root 3x minus x squared dx. Here we need completing two square two. Okay, maybe I'm doing separately. 3x minus x squared, it will be, take it minus, we have x squared minus 3x. It's mean minus, I have inside x minus, because I have minus 3x, and half of 3, it will be 3 halves. And all of them square and subtract constant, because we don't have third terms, it will be 9 fourths. Open outside parentheses, we have minus 9 fourths give us 9 fourths minus x minus 3 halves square. Great. This means our integral, we can rewrite and plug in star here, and this means star equal. Our integral, it will be dx from 3 halves to 9 fourths, integral from 3 halves to 9 fourths square root 9 fourths minus x minus 3 halves square. Okay. Constant minus function inside root. This means you have formula number 1. Great. What is u in your situation here? U is x minus 3 halves. What is a here? 9 fourths. A squared is 9 fourths. This means a is 3 halves. Great. Here we have arc sine x minus 3 halves over 3 halves. and x changing from 3/2 to 9/4 equal. If you plug in 9/4, you and 9/4 minus 3/2 and then divide by 3/2, you have 1/2. This means here is equal arc sine 1/2. If you plug in 3/2, you have 3/2 minus 3/2, 0. This means minus arc sine 0 equal arc sine 1/2, it will be pi over 6. Arc sine 0, it will be 0. This means we finish solving our problem. Okay. Now I spend more time for solving some problems as similar for your homework. Okay. And for example, number 8 from your textbook, it will be integral dx over x root x fourth minus 4. Okay, here is substitution, and substitution because I need inside root function square. This means u square, it will be x to the fourth. This means u, it will be x square. Du, it will be 2x dx. Great. Now we need prepare our integral for plugging our new variable. What do you have here? I need numerical 2x dx. Great, I write 2x dx. But what does mean I write 2 here? I can write 1/2 in the front my integrals, it's no problem. But what about x? This means I need to write x as denominator. I have x there, this means I have x squared x fourth minus 4. Great. Now we can write 1/2 du u because x squared is u, and we don't need any absolute value because it's always positive, and u squared minus 4, who I write is like 2 square. Great. Now we're ready for write our use our formula. 1/2, this is 1/2 because we have 1/2. Then we have 1/2 because our a is 2. And then we have arc secant absolute value u over 2 plus c. And then we need to remember what is u is, and it will be 1/4 arc secant absolute value x squared, it will be x squared. This means x squared over 2 over 2 over 2 plus c. Okay, great. One more example, number 16. It's doing substitution too. What we have here. We have 16, it will be integral 3 over 2 square root of x 1 plus x dx. What we see here, we always have constant plus square function minus constant minus square function, but always square. This means looks like x is need to be u square. This means u, it will be square root of x. Du, it will be dx over 2 square root of x. But we exactly have this part, right? Dx 2 square root of x. You see? This means no problem now. Rewrite our integral, plugging all of them. This will be 3 integral du over 1 plus u squared. But this is exactly arc10. Great. We have 3 arc10 u plus c, or 3 arc10 square root of x plus c. Great. Now we have two questions when we need found complete to the square. I'm doing number 34 and 38, and we can easily see how it's work. 34, for example, you have integral from -2 to 2 dx over x squared plus 4x plus 13 equal -2 to 2 dx is c. Here it's looking for first two term my trinomial, and this is show me you have x plus half of 4, it will be 2 square, subtract 2 square, it will be -4 plus 13. Okay, write one more time, there's no problem. It will be -2 to 2 dx x plus 2 square. -4 plus 13, this will be 9. This means here I have plus 3 square. And now you can see you have exactly arc10. And a is coefficient is 3. U is x plus 2. Du and dx, this situation is same. This means we don't need any more substitution or anything. And I can write 1/3, because 1 over a, arc 10 x plus 2 over 3, plugging from -2 to 2, plug 2, you have 1/3 arc 10 4/3, and if you plug in -2, you have arc10 0, but arc10 0 is 0. This means this is good enough answer. Okay. Number 38, we have integral 2 over square root minus x squared plus 4x dx. Okay, maybe we're doing separately this here too. Minus x squared plus 4x. It will be minus out x squared minus 4x. Here is minus x minus 2 squared minus 4. Finally, it will be 4 minus x minus 2 squared. Okay, this means my integral, it will be 2 dx, and here I have a root from 4, it means 2 squared minus x minus 2 square. Okay, it will be constant minus function, it will be an inside root, that means arcsine. And here I have twice is because we have two coefficients. Remember, in the formula arcsine you don't have any coefficient in the front. And here we have x minus 2 over 2 plus c. We finish. Okay. And a last one for today, it's question number 66. Then if you open book, you have some graph there, and you need found area between this curve and on this interval. Give us integral from, this is number 66, area will be integral from 0 to natural logarithm square root of 3 4 e to the power x over 1 plus e to the 2x dx. I think we use substitution, but it's our work more clear. U here is e to the power x. Du will be e to the power x dx. And now my integral, it will be 4 du over 1 plus u squared. Great. It's exactly table integral, but because we're doing substitution and we don't want to go back for our old variable, this means now I need to evaluate. What is will be value u if x is equal 0? It will be e to the power 0, it's minus 1. What is value u if x to the natural logarithm square root of 3? E to the power natural logarithm square root of 3 is exactly square root of 3. And now we have 4 arc 10 u, whereas u change it from 1 to square root of 3. It will be 4 arc 10 square root of 3 minus arc 10 1 equal, okay, it's mean 4 arc 10 square root of 3, whereas tangent equals square root of 3. I think all you remember it will be pi over 3, whereas tangent equal 1, it will be pi over 4, okay. 4 times pi over 12 pi over 3. This is our final answer. Okay, this is all material what we covered for first week. If you have any question, write email for me, or we work Thursday together in our office time, and I try to answer it for all your questions. Remember, Friday you have first quiz covered material from your homework. Okay. Why? I try close to here.